Hello, today we will be talking about the geological distribution of the Cephalopoda. As you know, the Cephalopoda, they are said to be the highly evolved form of mollusks. Cephalopoda is divided into three orders: Nautiloidea, Ammonoidea and Dibranchia. Nautiloidea is an order which has some very defined characters, like it has external shell and the suture is simple and slightly curving. Shells are sometimes straight and sometimes coiled. The straight shelled nautiloids are orthoceras and the coiled nautiloids are the nautilus itself. Then comes the Ammonoidea. Ammonoids have always an external shell. Sometimes it is straight also, but many at times or most of the shells they are found in the coiled condition. The suture is complex, complicated suture is being found. Due to this complicated suture pattern, the ammonoids have a very short geological range and a very wide horizontal range, due to which they are excellent index fossils. Then comes the third order, that is the Dibranchia. Dibranchs are they have internal shell and suture lines are almost absent, and the forms resemble the modern day octopus. In the present lecture, we will be discussing about their geological distribution, their ecology also to some extent. Here it is very important to tell you that it is a very simple law of nature, that those that have simpler attitudes, they are long ranging, and the organisms that have a complicated and a complex attitude, they are very short term taxa or short term organisms. This particular trait is best exemplified into the Cephalopoda. Like for example, if you see that the nautiloids have simple suture, simple and slightly curving suture. So, they are still found nowadays and they have evolved before the ammonoids. But if you see the ammonoids, they have a complicated suture pattern, and due to this complicated suture pattern, they evolved later and they became extinct, and they became extinct at the end of the Mesozoic. This also tells that we must learn from the paleontological record that simplicity is the best trait to be adopted. That is a very natural trait. Now, you may be surprised that why complicated suture pattern into the Ammonoidea has led to their extinction. The reason is very simple. Why a particular organism should adopt or should evolve to a complicated suture pattern? Any organism wants food and space. That is the two main constraint, and in that time the main constraint is food and to explore more ecological niches to investigate for the food. Now, they are all aquatic marine organisms, and therefore, the shell has a constraint of the hydrostatic pressure. So, when the suture is folded and refolded, then the area increases, as you may be knowing that pressure equals to force upon area. So, you cannot reduce the hydrostatic force, but by increasing area you can reduce the pressure. So, if you increase the area, force will be constant, but pressure will be reduced. So, since they complicated the suture line, they have increased the surface area, because of which that pressure, the hydrostatic effective pressure, it decreased, and due to which they could take their shells to the deeper level and they could withstand hydrostatic pressure. But They have increased their horizontal range, their ecological niches, but biologically they were not meant to live for that entire big horizontal range. Like for example, I am adapted to live in a very narrow range of temperature, pressure, oxygen level. If you put me into the Antarctica, I will die. So, that means if you increase my horizontal range, my vertical range would automatically decrease. So, because of the greed to take more of the nutrition, more of the food, they have increased, they have complicated themselves and they have increased the ecological niche, and that led to their extinction. Now, let us talk about the distribution of the Nautiloidea. At the present day, the nautiloids are represented only by 4 species of nautilus, which is found in the Indian Ocean and East Indian archipelago from Sumatra to Fiji. The nautilus is a very successful cephalopod nowadays. It lives in fairly shallow water. Either it crawls on the sea bottom by means of some tentacles, or it swims, but sometimes it also rises to the sea surface. Many of the extinct nautiloids, they probably fed the similar benthonic mode of life. This Nautiloidea group, it appears very early in the geological series compared to their ammonoid counterparts or the dibranchiates. The early forms, they constitute the slightly curved cones, and then from them or otherwise subsequently straight and spiral shells appear. But straight or nearly straight forms, they predominate into the Paleozoic and Triassic. Volborthella and Sorella, they are found in the lower Cambrian. They are curved forms and they represent the very early nautiloids, and it resembles the modern Cetoceras, at least externally. In the Ordovician, which follows right after the Cambrian, the nautiloid population has increased in importance. So, you get a huge number of nautiloids into the Ordovician time, and the assemblage, it includes the Endoceras, the Plioceras, the Lilioitis, etc. And this group attains its maximum diversity and maximum development into the Silurian, and it is the Silurian in which the number of species is greatest. Orthoceras, Gomphoceras, Phragmoceras, Ascoceras, and the other helicoid genus Trochoceras, it is found fairly constant in that time. Then it decreases slightly in importance in the Devonian and Carboniferous, and is very poorly represented into the Permian. The chief genera into the Carboniferous, they are Orthoceras, Rheonoceras, Poterioceras, Descitoceras, Vestinautilus, etc. The only genus which extends beyond the limit of the Paleozoic period is Orthoceras. Orthoceras, at this time, I would like to recall that it is a orthoconical form, having orthoconical form, straight septa, and it has a straight siphuncle also. It has external shell, and it is found commonly in Triassic. Nautilus occurs for the first time in Triassic and is very abundant in Jurassic and Cretaceous, when its distribution seems to have been worldwide into the Tertiary, and then it becomes little rare. Etruria is a genus that appears into the Eocene and the Miocene. So, it is the latest arrived form of the nautiloids. Now, we will be discussing the distribution of Homonoidea. The Homonoids have a shorter geological range, as I told you, compared to the Nautiloids. The earliest representatives being found into the Lower Devonian and the latest in the Chalk. Lobobactritis or Bactritis is found into the Middle Devonian and has often been regarded as an ancestral form of Homonoids, but is now believed to be a secondarily uncoiled goniatide. It exhibits a straight tapering shell with a simple superior lateral lobe. Throughout the Devonian and Carboniferous periods, the goniatids were dominant, with climanids abundant into the Upper Devonian. In the history of the various groups of goniatids, there is a general tendency for the suture line to become folded. To become folded, that means you have the rounded saddles, rounded lobes, then rounded saddles, frilled lobes, then frilled saddles, frilled lobes, and then you have the auxiliary lobes that develops on the lobes as well as on the saddles. So, you observe a very general and a gradual tendency for the folds to be developed and become advanced into the Homonoids. Then the septal necks that changed from retrosiphonate to the prosiphonate, and for the sinus in the external margin of the aperture to decrease in size and then ultimately to disappear. The various gonatid stocks that persisted into the Permian, it gradually took on Homonoid characters until the Upper Triassic, where the maximum development was reached. Although most of the Homonoids in the Triassic, they evolved complicated suture lines, some like Ceratitis that remained relatively simple. The number of genera in the Triassic is very large, but not one seems to have survived into the Jurassic period, and only one family, that is Phyloceratidae, it passed from the Triassic into the Jurassic. So, that apparently all the later Homonoids must have been derived either directly or indirectly from that family. Two families, the Phyloceratidae and closely allied Litoceratidae, are remarkable. In what way they are remarkable? They are remarkable in the sense that they persist with but little change throughout the whole of the Jurassic and Cretaceous periods. Numerous other groups of Homonoids were evolved in Jurassic and Cretaceous, but the possibilities of the variation were limited, and the same type of wall section, ornamentation and the suture lines were often reproduced in the various families and at different horizons. In the Triassic and Jurassic, there are some genera in which the shell has become secondarily straight, that is Bhabdoceras, Acuriceras. Partly uncoiled forms are also found like Choristoceras, or coiled into the helicoid spiral, that is Cochloceras, Spiroceras. These features become much more remarked or remarkable into the Cretaceous, where we get such genera like Hemitis, Macroscaphitis, Baculitis, then Scaphitis forms. Then these forms are believed to have been derived from the various Litoceratid Homonoids. In the Cretaceous, there is a tendency in some stocks for the suture lines to become simplified, and occasionally it returns to the type seen in the Ceratitis. On the other hand, Endoceras, the latest of all the Homonoid genera, there is no sign of simplification. Its suture line with 75 elements of lobes and saddles recalls the acme or the peak of specialization among the Triassic Homonoids. Now, as I told you that that some of the forms, they took the coiled uncoiled forms, and the early portions were coiled and the later portions were uncoiled. The coiled portions and uncoiled portions, they have a very distinct feature. The coiled version, it has the triangular chambers, whereas the uncoiled or the straight forms, they have rectangular chambers. This seems to have been because of some selection pressure or some ecological constraint is something which is not clear up to yet. Now, we will be discussing the distribution of geological distribution of the dibranchia. Dibranchias, they are characterized by first the internal shell, and then they have the central siphuncle, then alveolar rings are there, which is subcentral position, then you have a phragmocone, then prostracum. So, these are the morphological features which characterize the dibranchs. Some of the structural geologists also use one of the dibranchs called as belemnitis for the strain, longitudinal strain estimation. The dibranchs are more numerous and more varied in existing seas than they were at any former period. Some forms are pelagic, others are abyssal, but the larger number are found into the littoral region. Littoral region means the region that occurs between the high water line and the low water line, and these forms are distributed in provinces similar to those of the other mollusks. Typical littoral genera are octopus, sepia. The suborder Decapoda is represented in the Triassic by Atrocytus, Olacoceras, Dictyoconitis and Phragmoteuthis. In the Jurassic and Cretaceous, belemnitis are the chief forms and are especially abundant in the argillaceous beds. However, they are also found in great abundance into the arenaceous beds also and into the carbonate rocks as well. Other Jurassic genera are Geoteuthis and Beloteuthis into the lias, Belemnoteuthis and the Plesioteuthis into the upper Jurassic, Belemnitella and Actinocamex are limited to the chalk. Let us talk about the tertiary. The tertiary dibranchs are relatively rare, but several genera are found like Belosepia, Sepia, Belemnosetta, Belemnosts or Belemnosis, Baloptera, Spiroleuthera and the Spirolistrocina. The living form Spirula is not definitely known to occur as fossils. The suborder Octopoda is represented by the Pelsioctopus that occurs into the chalk specially, and Argonauta that occurs into the Pliocene. We see that there are more number of the dibranchs octopuses that exist into the modern sea now than they have occurred into the fossil record. This is all for now. We will be discussing about more of the paleontological groups in future. Thank you very much.